Difference between distance and displacement. We'll define distance is equal to the total length of travel So let's take an example. Here is Johnny. Starting from here, John is going to walk to his friend's house right here. That's the house. I'm going to draw some. Which is 2 miles away. Then from there, him and his friend, they're going to travel to the lake here. There's a lake. The water, they're going to go swimming. And that lake from his friend's house is 4 miles. So what is the distance traveled by Johnny? It's 2 plus 4, which is what? 6 miles. Take the two numbers and add them. Different example. After the class today, you decide you're going to leave Springfield and go to Boston. So you're going to leave Springfield, Mass. You drove all the way to Worcester. How far Worcester from us? 40 miles roughly? 35 miles from Springfield? Let's say 35 miles. Once you get to Worcester, you realize you go in, you have some business to do in Boston. You forgot your computer or your wallet, whatever you need to put, your passport. Let's say you want to renew your passport. You go into Boston to do it. You go on vacation. You get to Worcester because, oh, I forgot to bring my old passport. I need that one. So you turn around. You come back to Springfield now. You pick up your passport and you drive back to Boston. From Springfield to Boston, roughly 70 miles. What is the distance traveled by you? Is the 35 miles from Springfield to Worcester plus what? The 35 miles to go back from Worcester to Springfield plus the 70 miles to go from Springfield to Boston. It's 140 miles. So what about displacement then? We know what distance is. Let's look at displacement. Displacement is the change in position. Delta in math. In math and science, that little triangle is called delta. Delta x is the change in position. Where is your final position in relation to your initial position? So it's x final, that's your final position, minus, for initial we use either I or O. So a lot of times you'll see me write this as x final minus xo, x initial. It's the same thing. So it's your final position minus your initial position. Final position minus your initial position. That's what displacement or change in x. Let's go back to that example, to Johnny. Remember Johnny? Start from here. Walk 2 miles to his friend's house. And from his friend's house, they walked how many miles? 4 miles to get to the lake. What is this displacement here? It is the final position minus the initial position. This is my initial position. I'm going to measure the distance from that point. This is my x sub O, or x sub I. This is my final position, x sub F. How far, Johnny, from this point now? 6 minus 0, which is what? 6 miles. So his displacement here is the same as his distance. That's why a lot of people will use distance or displacement to mean the same thing. In some cases, they are the same thing. Now in the next example. Here's your trip to Boston. You start from Springfield. You went all the way to Worcester. Back to Springfield, then to Boston. This is your initial position right here. This is your final position right there. So your displacement here is what? Your final position minus your initial position. What is your final position? 70 miles away. What's your initial position? 0, 70 miles, your displacement. Is that the same as the distance? No. So when you go in straight line, the two of them really gives you the same answer. But when you zigzagging, it's not the same thing.
Will initial position always be 0?
Well, you can make it any number, but I always make it 0. That's your reference, because you measure. Because if you make the initial, let's say using a measuring tape, and instead of using the 0 to measure that, I use 5 miles. Then that distance becomes what? 5 plus 6, 11, right? Because if you have a tape, let's say you're measuring the distance, the length of a board, but somehow the tape was missing the first 10 centimeters. So it wasn't starting at 0, starting at 10. So this becomes 10. Then that distance is not going to be 6 now, it's going to be 16. So these answers will not change regardless where you make the starting point is. But to make the math easy, might as well make it 0. Here is a question for you. You decided there's a soccer field, a football field. Football field is what? 100 yard. What's the width of a football field? Anyone? Let's say 80 yards. We'll just make that up. I don't know. At the end of the football field, there is actually half a circle. If you start from this point, that's where you're going to start from, and you walk all the way around till you get back to this point. So you decided, here we go, there's a picture of you. There's going to be going on the outside. You're going to walk this way. I just erased the 100. All the way back to here, the beginning. The question, can you tell me what's the distance traveled by you? And what's the displacement? Let's begin with the displacement. That's much quicker and easier. Your displacement is 0. Valentina says 0. Why? It's the final position minus your initial position. This is your initial position right there. I'm marking that as the 0 mark. Your final position is what? Same spot. So 0 minus 0 is 0. I don't care how many times you did that track. If you stop at the same point, your displacement is 0. Your distance traveled, that's a different story. Why? Because it's that piece, the top piece, which is what? 100. You're going to add to it this piece, which is, I don't know what that is. You're going to add to it this piece, which is 100. and you're going to add to it that piece. Well, I started from here, but if I started from this end, I got to add half of that little piece here. If you start from here, you get this piece plus 100 plus that piece plus 100, now plus that piece from here to there. And when you think about them, these two pieces are 200. But what about these four pieces, the three pieces that you see here? You get this piece, let me draw them. You get that piece from here to there. Add to it this piece. Add to it that piece. Isn't that a full circle when you take this half and this half, put them together? This is 80 feet. What is the distance on the outside called? Circumference. And the equation for the circumference is what? 2 pi r, or 2r is d. That's diameter. But if you want to use that, it's 200 plus 2 pi, and what's my radius? How about 40? Diameter is 80, right? Radius is 40. So it's equal to what? 200 plus 80 pi. That's the distance traveled. Now just a little warning here. If they ask you for an exact answer, give them that answer. Leave it that way. If they said exact. They don't want you to use 3.14 for pi. They want to leave pi as pi. If they said round your answer, then we use the calculator for that. We go 200 plus 80 pi it is 451.3. I'm not paying attention to significant figures. 451.33 yards. That's one lab. A mile is actually 1,760 yards. 1,760 yards. So one lab here, if you divide that by 451.33 divided by 1760. 1760. Each lab is a quarter mile. Oh yes, you're right. But it's still like roughly 0.2 for a quarter mile. So it takes 4 laps to do 1 mile. So if you're seeing people actually on a football field or soccer field going around, every 4 laps, that's a mile, roughly. So that's a quarter mile, approximately. That's approximately, squiggly line, a quarter mile. So that's the difference between displacement and distance. Good. I can stop that one.